Okay, this is the second part of the same problem we were solving. What is the tension in each of the ropes of the motionless swing if the two ropes share the load equally? So in this case, as you remember, the mg was 660 newtons, and of course the ty's must face the mg, so they should be half of the mg each, because you know that the t's are equal in the ropes because the t forces are sharing the load equally, so the t's are equal. And of course, as I said, they would be dotted because I'm gonna put the I'm gonna put the components of them instead. So these are the t's, this is the ty, of course two of them, and the tx's will cancel each other, but the ty's add up to make up for the mg. So the ty plus ty equals mg, because they are equal, 2 ty's equals mg, and therefore the ty equals mg divided by 2, so the ty equals 660 divided by 2, which is 330. So, and the ty, now if you pay attention in here, you can see that these are parallel, right? Because these are vertical. So if this is 20, of course this is going to be also 20. So this one, they're both equal and they're both 20. So of course the ty's, which are equal to each other, I only did one of them. The ty would be the adjacent in this triangle to this angle, so it would be t cosine theta. Therefore the t equals ty divided by cosine theta, and the t equals of course 330 divided by cosine of 20 in this case, right? Because our angle is 20, and the cosine of 20 is 0.94 if you find it with calculator, and the answer would be 351. This part you don't really need to do, you know, as I said, you don't need to use calculator. For me, up to this part is enough, but just in order to check it with the answer sheet the answer in the end of the book, because this is the book, so I just used one example from the book just as an example. Just I won't do much of this, so for me this part would be enough. This is the final answer for me. As I said, I'm not a fan of using calculator in high school.